fundamental theorem of calculus is a rigorous relationship between a function and its derivative, the integration or vice versa. And one way of considering it has to do with this relationship, but we might not know something with regards to the limits of integration, and we might not know something about the function in general. We know some things about it. So we're saying there's a function that's equal to the integral from 1 to x of t squared dt. And the second fundamental theorem of calculus lets us know something directly about the derivative of f of x right now. But if we look at this longhand, if we were to integrate normally, t squared with respect to t, this would be 1/3 t cubed. We're integrating from 1 to x. And if we substitute in the upper limit, this would be 1/3 x cubed. The lower limit, minus 1/3. That's what the original function is. Well, what about the function's derivative? Well, the function's derivative, the derivative of 1/3 x cubed is simply x squared. And the derivative of negative 1/3 is 0. So I know that the derivative of f of x is x squared. But I could have arrived at right from this point, because the second fundamental theorem guarantees me some things. And basically, notice if I just substitute in x directly into that, f prime of x must be x squared. Well, that's strange. One of the things to consider is if you do this process every time, you will always end up with a constant, and when you take the derivative, it will be 0, and you will just be left with what you substituted in. Now notice, this is more complicated, only slightly, if our limit of integration, let's change it to x squared, look at the same thing. If we do this longhand, this would give us 1/3 t cubed squared to 1. By substitution, x squared cubed is x to the 6th minus 1/3. The original function f of x, which means that f prime of x must be 2x to the 5th. Derivative of 1/3 x to the 6th, 2x to the 5th, derivative of negative 1/3, 0. I could do that. But if I use the same idea via the fundamental theorem of calculus, what will always happen with regards to what the derivative of f of x is, if I substitute in x squared, I will get x to the 4th, and it should be 2x to the 5th. Well, why isn't it matching up yet? Because I also need to consider the derivative of the upper limit of integration. The derivative of x squared is 2x, and this is because of the chain rule. And notice their product is 2x to the 5th. You might be saying, well, you didn't do that up here. Well, yes, I did. The derivative of x is 1. So in that initial case, it didn't change the outcome. Because of the fundamental theorem of calculus, if a function is being expressed as an integral, I can know something about its derivative directly rather than going through this. And the reason that's beneficial is sometimes it's very difficult to integrate something, and I'd still like to know something about its derivative.